Hello, thank you for joining this booth talk. In this booth talk, we wish to show you how OpenMP has been used to parallelize modules of autonomous driving software platforms. We will start with a short introduction, then describe the Autoware autonomous driving platform and how OpenMP has been used to parallelize module in it. Then we will go into the Apollo artificial intelligence platform and also discuss how OpenMP has been used on this platform, and finish off with a short conclusion. So let's first show you the driverless car. So this consists of many sensors around the car with cameras, radars, LiDAR, GPS receiver, and an antenna. And in the trunk, a PC or embedded system, which will be used to analyze the data coming from the sensors, then compute the next trajectory and pass on control to the car for following this trajectory. So you can imagine the execution time of the autonomous driving system is essential for the safety of the car. So the human driver reacts within 300 milliseconds in general, and the goal of the autonomous system is that the system reacts within 100 milliseconds. So this booth talk will discuss how OpenMP has been used to speed up autonomous driving software running on an embedded system. Note that this talk is the subject of a blog on the OpenMP website, where you will be able to find all the references to the articles used for this work. So go to www.openmp.org/blog to find the blog. The Autoware platform. It is an autonomous driving open source platform, which was founded in 2015 by Shinpei Kato of Nagoya University. There are 60 members, and it's used in 30 vehicle models. The platform has been qualified to pilot driverless vehicles on public roads in Japan, and it's currently used in 15 autonomous driving projects around the world. So this is the design of the software. First, you have a sensing step. You gather all the data from the cameras, the radar, the LiDAR, GPS, and pass down to the computing phase, which will first is a perception step. So to localize the car, where it is located, detect the objects around the car, make a prediction of what will happen. Then a decision step is done to decide the next trajectory of the car, and which is handed on to a planning step for the planning of route, velocity, etc. We finish off with the actuation step, where the trajectory is passed on to the vehicle control system, and then the next trajectory is followed. So the OpenMP API has been used to parallelize two modules in this system. With first the Euclidean clustering module, which is a module that is used for object detection based on the Euclidean clustering algorithm. And the second is the points-to-image module, which is used in the visualization of the maps. So the following OpenMP features were used in the parallelization. Firstly, the OpenMP target teams distribute. The target is a construct with which you identify a piece of code which will be run on the accelerator. And the second feature used is that memory was allocated on a memory that is accessible by both host CPU and GPU. This is a basic feature of embedded systems. Note that this work was performed by Lucas Sommer of TU Darmstadt. The reference can be found in the blog on the OpenMP website. So Lucas used as target platform the NVIDIA Jetson AGX Xavier, which is an embedded system with an 8-core ARM CPU and a 512-core NVIDIA Volta chip. So the results that Lucas Sommer attained was that he managed to speed up the Euclidean clustering module by a factor of 3.25 by executing it on the GPU. And the point-to-image module had a speed increase of 2.5. The next platform we want to discuss is the Apollo Artificial Intelligence Platform, which was founded in 2017 by Baidu. So this platform is used in Apollo vehicles, which consist of minibuses, valet parking vehicles, driverless taxis on one of the sites of the 2022 Winter Olympics. So Baidu has plans for 1,000 fully autonomous vehicles in collaboration with BAIC, which is the Beijing Automotive Corporation. And the first batch of T4 road test licenses was awarded in China in 2019 to Baidu. So the design of software is shown here. Again, it has a localization step. Where is the vehicle located? Perception of the objects around it. It's using the high definition map. The system does a prediction of different routes, which are passed to the motion planning module. The motion planning decides what will be the next motion of the vehicle, and that is passed through the vehicle control. So this study focused on the optimization of the motion planning module. Note that this was performed by Hongyu Tsai, Yuan Chen, and Yang Wang of Intel. So friends, go to them, and you can find the reference to their work on the blog on the OpenMP website. So the motion planner has first a reference line generator. Different lines are generated. Those are optional lines of action for the vehicle. So each of the lanes is then optimized. So there's a path decision and a speed decision made for that lane. The different lanes are then passed on to the reference line trajectory decider. And once a trajectory has been decided, this is done past a physical car directly generated and passed on to vehicle control. The target platform used by the authors was firstly the Intel Atom CPU with a x86-64 architecture and of 2.1 gigahertz with 16 cores and a 16 gigabyte of memory. So the loop candidates for parallelization were identified by analyzing all the loops, the CPU time, the loop trip count, the loop dependence, and then the loops that were selected, their OpenMP multi-threaded but applied. And by this step, the performance improvement was a factor of 1.4 if 8 threads were used. Note that no gain was obtained with more than 8 threads. So these two examples, the Apollo AI platform and the Autoware platform, where OpenMP has been used to optimize specific modules, show that OpenMP has a role to play in the autonomous driving space. And subsequently also, since OpenMP was used to optimize software on embedded system in cars, it also has a role to play in the embedded systems space. These are just two examples of this role. Thank you for the listening, and let me finish off by mentioning that you can find on the openmp.org website or the specs of OpenMP API, forum, reference guides, and more. You can also go to the SC21 page on the OpenMP website where you can find videos and PDFs of all presentations. Thank you for your attention.